Listening Comprehension in Scientific English by Jonathan Upjohn. Unit 9, Function and Purpose. Solar Waste Disposal. Part 1, Keywords.
Aim. Array. To avoid. Beam. To claim. Goal. Harmful. Merely. Purpose. Sample. Sensor. To shift. Target. To track.
New words.
Test chamber. Byproduct. Disposal.
Do you recognize these homographs?
Dioxins. Ultraviolet light.
Part 2, Exercises. Now, listen to the text and answer the questions. Stop the recording when necessary.
Unit 9. Solar Waste Disposal. As we draw towards the end of the 20th century, it's becoming increasingly clear that one of the primary objectives for modern technology within the next few years will have to be finding ways of limiting the production of harmful toxic waste. As a rule in this context, solar energy is often regarded as being the ideal alternative energy to replace polluting fossil fuels. However, sun rays are not restricted to being used merely as a source of heat. They can be used for other things too. Two research teams in America, one in Colorado and the other in New Mexico, are currently working on different techniques to use the sun's beams in order to actually destroy toxic waste. They claim that the systems they are designing have a double advantage. Besides being more efficient than conventional incineration techniques, they will also avoid the production of toxic byproducts, which are emitted when hazardous waste is burnt. Harriet Green is here to explain.
The first project comes from the Solar Energy Research Institute, working in Colorado. Their aim is to design a system that can destroy hazardous compounds, like dioxins. The team uses solar energy to provide a heat source, and by concentrating the sun's rays at several hundred times the normal intensity, it's possible to exceed temperatures of 1000 degrees C.
And what is the effect of this?
Well, when you reach temperatures of this sort, the dioxin is vaporized and broken down extremely efficiently. In a preliminary trial, they put a 10 milligram sample in a test chamber and were able to destroy up to 99.99% of the dioxin within 10 minutes. The Colorado team also claims that sunlight destroys dioxins at lower temperatures than conventional burning.
Is the New Mexico group using the same technique?
No, they're following a different line of approach. They've devised a system that uses solar energy in conjunction with catalysts to destroy toxic organic liquids.
And how exactly does it work then?
The liquids to be treated are stocked in large storage tanks, and before being pumped through the system, two catalysts, titanium dioxide and hydrogen peroxide, are injected into the fluid. The liquid then goes through a series of glass pipes fixed at the focus of an array of parabolic reflectors.
Bearing in mind the movement of the sun, how do they ensure optimum temperature?
Well, the whole system of reflectors is mounted on a mobile steel framework in concrete foundations. As the sun shifts position, sensors activate a tracking device driven by an electric motor, so that the reflectors follow the sun's path. The combination of ultraviolet light and heat generated at the focus of the reflectors trigger a reaction with the catalysts, and so the organic contaminants are destroyed.
But more practically, what in fact can this technique be used for?
Well, one of its principal purposes will be to clean up large quantities of contaminated water. For example, tiny amounts of trichloroethylene can be responsible for groundwater pollution. Trials have shown that concentrations of 12 parts per million were reduced to 50 parts per billion within 5 minutes. The team claims that the technique can also be used for treating PCBs, polychlorinated biphenyls, and pesticides, including cyanide compounds.
And how far on are they with their work? I mean, are they ready for commercial use?
No, not yet. That's still quite some time off. Both groups are only at the development stage. Neither of them plan to market these techniques in the immediate future.